The James Webb Space Telescope has once again redefined our view of the cosmos, this time by unlocking new secrets hidden deep within one of the most famous and well-studied explosions in modern astronomy, Supernova 1987A. When this massive star detonated in 1987, it lit up the southern skies and became the brightest supernova visible from Earth in nearly 400 years. Situated roughly 170,000 light-years away in the Large Magellanic Cloud, a small satellite galaxy of the Milky Way, SN 1987A has been under constant observation for decades. Yet until now, even our best instruments could only hint at the intricate structures hidden at its heart. With Webb's unmatched sensitivity and resolution, we now see the supernova remnant's core like never before. A striking formation shaped like a dark keyhole, glowing in ethereal shades of blue. This keyhole is a dense shroud of gas and dust, the debris cast off during the star's violent death. The dust is so thick that even Webb's infrared eyes, capable of piercing through most cosmic veils, cannot fully penetrate it, leaving the dark silhouette of the keyhole stark against the surrounding glow. Encircling this shadowed heart is a brilliant equatorial ring, an almost perfect band of gas that wraps around the central region and connects two delicate, hourglass-shaped lobes. This ring is ancient compared to the explosion itself, formed tens of thousands of years before the supernova when the dying star began shedding its outer layers. Bright hotspots sparkle across its circumference, the aftermath of the supernova's shockwaves slamming into this older material. These impacts create pockets of intense light that, with Webb's instruments, can now be traced even beyond the main ring, spilling their energy into the surrounding space. NASA scientists explain that these hotspots are the direct result of high-speed collisions, where the expanding blast front from the 1987 explosion meets the slower-moving remnants of the star's earlier life. But that's not the only revelation. Webb has also unveiled delicate crescent-shaped structures drifting far beyond the central ring, features completely missed by the Hubble Space Telescope in previous decades. NASA believes these crescents are the outermost layers of stellar gas flung away during the cataclysm, still glowing as they race into interstellar space. Yet, even with these stunning images, mysteries remain. Chief among them, the fate of the neutron star expected to have formed at the explosion's core. Astronomers know the conditions were right for such an object to exist, but direct evidence remains elusive. Webb's future observations aim to track subtle changes in the remnant's light and structure, hoping to confirm whether the long-suspected neutron star is indeed hiding within the dust. But SN 1987A is not the only dying star to reveal its secrets to Webb. The telescope has also turned its gaze to the famous Ring Nebula, a planetary nebula located around 2,200 light-years from Earth, bright enough to be seen through binoculars on clear summer nights in both hemispheres. Unlike a supernova, a planetary nebula marks the final stages of a smaller star's life, when it gently sheds its outer layers into space, leaving behind a dense white dwarf core. The Ring Nebula is an especially compelling target because its size perfectly fits Webb's mid-infrared instrument, MIRI, field of view, allowing astronomers to map its structure in extraordinary detail. The international research team, known as ESSENCE, used Webb's capabilities to capture the nebula's fine tendrils, knots of gas, and glowing arcs with unprecedented clarity. These new images reveal layers of history, multiple waves of ejection, intricate filaments of dust, and even signs of interaction between the nebula's expanding shell and surrounding interstellar material. Thanks to Webb's advanced infrared detectors, astronomers can now measure subtle variations in temperature, composition, and velocity across these structures. Every thread of gas, every glimmering arc, tells the story of a star's slow farewell, a process shaped by the same cosmic forces that will one day determine the fate of our own sun. From the violent birth of a neutron star to the graceful fading of a planetary nebula, Webb is capturing moments of stellar transformation with a clarity humanity has never before achieved. These observations are not just spectacular, they are rewriting our understanding of how stars live, die, and reshape the galaxies they inhabit. The universe is revealing its secrets, one image at a time. And with Webb's eye fixed on the skies, the story of our cosmic origins, and our ultimate destiny, is only just beginning to unfold. According to the latest release, the James Webb Space Telescope, positioned about 1 million miles, or roughly 1.6 million kilometers, from Earth, has unveiled astonishing new details about the intricate structure of the Ring Nebula. This celestial object, previously studied for centuries, has now revealed secrets that were simply beyond the reach of earlier telescopes. When scientists first reviewed the Webb images, they were amazed by the sheer abundance of detail. At the heart of the nebula lies the bright, glowing ring that gives the nebula its name. This ring is not a simple feature but is composed of approximately 20,000 individual clusters of dense molecular hydrogen gas, the very same kind of gas found here on Earth. Within the ring, astronomers detected a narrow band of emission containing complex molecules such as polycyclic aromatic hydrocarbons and various carbon-based compounds. This discovery was unexpected, as prior studies had not predicted the presence of such rich chemistry within the Ring Nebula's environment. Beyond the bright ring, Webb captured striking peaks extending in opposite directions from the nebula's central star. These peaks are especially prominent in the infrared spectrum, revealing details that earlier visible light images from the Hubble Space Telescope could not discern. Scientists believe these structures arise from molecules forming in darker, denser regions of the nebula where they are shielded from the intense radiation of the hot central star. Webb's infrared instruments, capable of detecting light invisible to the human eye, have been crucial in uncovering these hidden features. The telescope also provided unprecedented insights into the nebula's filamentary structure, revealing around 10 concentric arcs in the outermost layers. These arc-shaped rings were a surprising find, suggesting they formed roughly 280 years ago, during a phase when the central star was shedding its outer layers on its way to becoming a planetary nebula. This timescale is unusual and cannot be fully explained by current stellar models. One exciting theory proposes the presence of a companion star orbiting the central star at a distance comparable to Pluto's orbit around our Sun. As the dying star expelled its atmosphere, this companion may have influenced the formation of the concentric rings, sculpting the nebula's complex shape over time. Roger Wesson from Cardiff University highlighted that no previous telescope possessed the sensitivity or spatial resolution needed to detect these subtle but telling features. Webb's capabilities have truly opened a new window into the nebula's hidden past and ongoing evolution. Importantly, this is not the first time the James Webb Space Telescope has observed the Ring Nebula, underscoring the object's continued significance in unraveling the mysteries of stellar death and rebirth. The Ring Nebula's story also mirrors the broader history of human curiosity and astronomical progress. Discovered in 1779 by Charles Messier and Pierre Méchain during their comet searches, it was catalogued as M57 in the famous Messier catalogue. Early astronomers struggled to interpret its true nature, but today it stands as a symbol of astronomical archaeology, a relic that allows us to explore the life cycle of stars. This vibrant, glowing ring marks the remnants of a dying star transitioning into a white dwarf, offering a striking reminder of our own cosmic origins and fate. In fact, astronomers expect that in about 5 billion years, our Sun may undergo a similar transformation, eventually creating a nebula like this. Though of course, no human will be here to witness it. One detail that often surprises viewers is the unusual color palette in Webb's images of the nebula. Because the telescope observes in infrared wavelengths, light invisible to the human eye, these images appear black until processed by image analysts. Through sophisticated techniques, the data is translated into visible colors that highlight different aspects of the nebula's complex composition and structure. The James Webb Space Telescope continues to revolutionize astronomy, capable of exploring everything from the farthest reaches of the universe to the rings of planets within our own solar system. With each observation, it offers fresh perspectives and pushes the boundaries of what we know. So, what astonishing discoveries lie ahead as Webb continues its mission? We'd love to hear your thoughts. Let us know in the comments what mysteries you want the James Webb Space Telescope to unravel next. If you enjoyed this video, don't forget to hit the like button and subscribe to the channel to stay updated on the latest cosmic revelations. Thanks so much for watching, and we'll see you in the next adventure.